Okay, this problem here, we want to solve the following quadratic by graphing. So here we have a quadratic, and we want to know when does this quadratic equal 0? For which values of x would make this equation true? And the method that we learned to solve this by graphing is to basically pretend that this no longer is equal to 0, but I want to graph the quadratic y equals negative x plus 6 squared plus 4. So if I graph this and look for where my y value is 0, I'm essentially solving this quadratic by graphing. So let's go ahead and do that. This is going to be in vertex form, and this is my h value, this is my k value. So my vertex is going to be given as negative 6, comma, positive 4. So let's put that down right away. So negative 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. Here's my vertex. At this point, I'm ready to make a table and figure out what the rest of my values are. Let's put the vertex in the middle, negative 6, 4. Let's get a couple points to the left and get a couple points to the right. From here, I'm going to be plugging in x values for x and evaluating to find my y. So let's do that. Let's pick green here. So let's start off with y equals, let's start with negative 8. Negative, I have to be careful with my negative sign here, negative 8 plus 6 squared plus 4. So that's going to be y equals negative, this becomes a negative 2 squared plus 4. Now here I have to be a little careful with PEMDAS. I'm going to evaluate the exponent first and then take the negative of whatever that is. So I've got y equals negative 4 plus 4, and this is going to be a negative 4 plus 4, or 0. Remember, the nice thing about quadratics is I have some symmetry here, so this is going to be the same as this value here. If you don't believe me, go ahead and plug it in. Let's try the next one, negative 7. Let's go to red here. So y is going to equal negative of negative 7 plus 6 squared plus 4. Or y is going to equal negative of, this becomes negative 1 squared plus 4. So y is going to equal negative 1 plus 4. And that looks like that's going to come out to be a positive 3. So we'll plug in a 3 here and a 3 here. And let's plot the rest of these points. So I've got, let's start with over here, negative 4, 0, 1, 2, 3, 4. So we're going to plot this point here, and then I'll plot my negative 5, 3, negative 5, 1, 2, 3, and one over here. Looks like this one's kind of cut off, but it's going to be just about here. So there is my parabola, and this should make sense. It's concave down since I have a negative a value. Just a little reminder there. So my solutions, remember, I'm going to be looking for when I graphed the equation y equals all of this. It gave me the shape, but I want to know when this parabola is equal to 0. So I want to know when y is equal to 0, and that's happening here and here. So my solutions are going to be x equals negative 8 or negative 4. I could algebraically verify these solutions by plugging each one of those in one at a time and solving, and I should get back out a 0. So that is how you solve by graphing. We're graphing a quadratic that's set equal to 0 and then looking for the roots.